remembering them all. So that's why I like. So basically, we start with triangles. We classify them, and then we started quadrilaterals. We spent about 2 days on triangles, 20 minutes yesterday on this, and today is going to be basically quadrilaterals as well as tomorrow. And then Friday, we're going to start polygons, which is basically encompassing everything. So you have your pentagon, hexagon, heptagon, decagon, all those gons, right? It's going to be a gon show. Just a reminder, our geometry test is going to be happening next Wednesday. Yes, it's a short unit, right? It's day 5, I think. So what does that mean? I have you right after lunch, right? Odd day. So if it's on the video even, if you want extra time, come in 15 minutes before class starts. So, right, you come in before lunch ends basically, so 15 minutes before, and you come in, you set up, I give you the test, off you go. And that'll be your extra time. So it's on you to get it, right? Like if you want it, come in earlier. It's always better to be done sooner and then be okay, right? Than to not have enough time. So that's how I'm going to do that. And that should solve that problem of some, like if you run out of time, this is your chance to make sure you have enough time. Okay, so I'll remind you of that when we get closer. How many pages? Pages are deceiving because, well, I'll tell you, it has about 8 pages. But it's because there's so many diagrams, right? Diagram, diagram, diagram. It eats up, one question eats up a third of a page sometimes. So pages, it's about the same. Like you should be able to finish it in the full period. There will be multiple choice, 10 questions, multiple choice. If I were you, I would leave those for the end. Like I would skip the multiple choice, do everything else, then come back to the multiple choice. I don't know. I find that if time is an issue, multiple choice is quicker to do because they don't take long. But that way you've done all the other stuff. Like because let's say you don't do any of the multiple choice, you lose 10 marks, which I don't think will happen. But as opposed to losing multiple marks for every question you miss in the back, right? So here we go. Right? Does that answer? Yeah. Properties of quadrilaterals, 4-sided. So sum of angles is always 360. Remember that. Remember your congruency symbol. Rectangle and parallelograms, they're related. And then we talked about rhombus and square. And the thing that was very new here is that diagonals meet at a 90 and that all sides are congruent, right? So I will highlight that part because that makes it different than the other two. All sides are congruent, right? So the highlighted part makes a rhombus and a square different from a rectangle and a parallelogram. Can I also add this? I will add, because I tell you that the diagonals meet at a 90 here. On top, on this section here, how about we write down diagonals do not meet at 90. You're just going to have to trust me that that's what it says there. Make sure you write down diagonals do not meet at a 90 degree for the rectangle of the parallelogram. Right? It is true for the rhombus and the square. Very important distinction to make. And you'll see later, I'll make you sketch a lot, even on the test. And it takes probably half a minute less, and it's 2 marks, right? So if you have 3 of those, that's 12 marks right there. And it's just you knowing how to graph these, and I will show you that. I'll make you practice today. Okay, so you got that. The diagonals would bisect and meet at a 90. Okay, that's it for those two. Cut them off. Okay, then we have our trapezoids. Let's put the trapezoids up top here, right? And there's two different ones we study in particular. There's the right trapezoid, and there's the isosceles trapezoid. Those are the two. The right trapezoid, the name kind of gives it away. It's basically a rectangle, and then it has a triangle attached to it. Whereas the isosceles almost looks like you cut off the bottom part of a triangle. Okay. And now we're going to look at some properties. So a right trapezoid, of course, has a 90 here, and it has a 90 up here. It has one pair of parallel sides. Okay. And that is basically it. So we'll write that down. One pair of right angles. One pair of parallel sides. And then we look over to the isosceles trapezoid. We know that it has one pair of parallel sides. It has, and I'm using different colors just to make it stand out. It has one pair of congruent sides. You should be able to read a diagram and write it out like this, just by looking at the markings on the diagram. Sorry, not parallel, sorry. One pair of, this is congruent, right? They're congruent. And then I'll tell you this, that these angles at the base are also congruent, okay? As well as the top ones here. So I go 2 and 2. So it has two pairs of congruent angles. You just got to make note of where they are, okay? They're kind of both base angles and both top angles are the same. That's it for trapezoids. And then we have one more, which is are the kites. I'm trying to think here. I think I will do that here. There are a few questions. There are a few questions that will ask you for the area of a trapezoid. And that one you probably don't remember. So area of a trapezoid it's A plus B times the height divided by 2. Say what? Right? Let's just make a quick trapezoid diagram. The top is A, the bottom is B, like the side length, and the height always cuts through like that. So if you add the top side, the bottom side, multiply that by the height and divide it by 2, you have yourselves the area of a trapezoid. I would probably say, just so it sticks out when you go through it, add it to your study sheet. All right, kites. Back side, I left that empty as well. So the kite, so this is how I want you to think of a kite. It's basically, this is just me saying this, okay? No textbook will tell you that. 2 isosceles triangles stacked. Okay? There are 2 stacked isosceles triangles. So if you graph it, you just start with one like this, and then have a longer one underneath it. That's basically how you graph a kite. So if the top one is isosceles, what do we know about the sides? We know that this one is going to be the same as that one, because that's the first triangle. And then we know that this side is going to be the same as this side. But there are no parallel sides, okay? That makes a kite different from the other ones. No parallel sides whatsoever. The only 2 angles that are the same on a kite are these ones. This one is the same as that one, right? So these 2 are the same, not the bottom and the top, only these 2. Okay? I'll make you graph another one because otherwise it gets too messy. But really, this could all be in one diagram. So make a small triangle and then a longer one. And all geometric shapes, 4-sided in particular, have diagonals. So if you go across like this, that's the short diagonal. And then you have a diagonal going like this. Okay? The only one that gets bisected is the one that goes horizontal, like this shorter one. This one gets bisected. That's it. And they look like they meet at a 90, right? They actually do meet at a 90. So you can add that here. And that's it. So you could have added this here, but I think it's too messy if you do that. So let's write this out. 2 pairs of congruent sides shorter diagonal is bisected. Bisected just means cuts in half. Equal halves, right? One pair of congruent angles and diagonals are perpendicular. Say what? Anybody know what perpendicular is? Do you remember? Younger years? It meets at a 90. It's a fancy way of saying meet at 90 degrees. That's what perpendicular is. Right? So redwood is perpendicular to McPhillips, right? They meet at a 90. So there you have, those are the properties. So diagram with the written part, so you can tell. I would say if you're pretty good at memorizing, just have the diagrams in your study sheet, right? Maybe combine them if you can do that. So here's where you need to, I'm going to cut this here. And I'm going to make you a sketch. Sketch each shape, comma, labeling two properties. And I want you to have three versions of it. So as if there are three different students answering that question. Okay, so sketch each shape, labeling two properties, and I want you to have three versions of each. So this is what I mean by that. So let's say for A, I am asking you to sketch a parallelogram in three different ways. So basically what you should have is, this is the first version you're going to make, second version, and third. You have the booklets, right? For this unit? Okay. So let me guide you, maybe guide you through one, because I think you're a little bit like, what do you mean by that, right? So let's say the first one is only two things, right? You go back, you cheat a little bit for now. You're like, okay, I know that this one is parallel to that one, and this side is parallel to that one. That's one property, right? Two pairs of parallel sides. Boom. One more. Well, I know that this angle here is the same as that, and that this angle here is the same as that. Like opposite angles are congruent. That would be 2 out of 2. Yeah. That would be a 2 out of 2. Let's do a second one. Let's say in this case, this student is saying, well, I want to talk about the diagonals. And with the diagonals, I know that the long one is being bisected, and so these two stretches will be the same. And the short one is also being bisected. That's going to be the same. That's one property, by the way. And let's say that now on top of that, you're just going to say, hey, I know that these two are parallel, and so are these two. That would be a 2 out of 2. And the last one, I want to say that the parallel is the easiest one almost. So these are parallel. And I'm going to talk about the length of the sides. I'm going to say that this side length is the same as this one. And this side length is the same as that one. And you're done. So these are 3 different ways that, and there are more, but these are 3 different ways that you could earn the 2 marks for a question like this. Let's try another one. How about a kite? I want you to sketch. I'm going to sketch them already. But I want you to have 3 different ones labeling 2 properties. But they cannot look the same. Each kite has to have two properties that you haven't used before in combination. And we're also going to do rhombus. That's the last one. Go for it. This is the time to practice. I think there will be at least 2 or 3 of these types of questions on a test. And then never mind ACs and quizzes, right? Rhombus, what is that again? That's a slanted square. All right. What was it, Ontario, that already announced that next March they're going to remove the mandatory mask mandate? Did you hear that? I don't know how they can predict that, but hey, that's what they did. All right, so let's say you're making a kite here. So you're like, okay, this is one property. Talking about the side lengths, that's one property. And then I'm like, okay, if this angle is the same as that one, done. So label 2 things, move on. So if you're talking angles, you have to label everything that's true about the angles. And in this case, it's only that these 2 are the same. Moving on. Let's say here you want to talk about the sides again. But now you're going to say the diagonals meet at a 90. Boom. Done. Let's say another one. I want to do something that I haven't done before. So I'm going to talk about the diagonals and knowing that these two cut and these sides are the same. Nope, just one here, 1 and 1. Right? These are the same, these are the same. And you told me that the diagonals bisect. Does that make sense? Can you wrap your head around that? Okay. Easy marks if you know what you're doing. Rhombus. All sides are the same. This angle is the same as that one. This is the same as that one. 2 marks. Bingo. This line is parallel to that line. This line is parallel to that line. Let's talk about the diagonals here. The diagonals meet at a 90. Done. Next, I will talk about the diagonals again. I will say that this splits that, right? So you get 2 halves. This splits that. And what else can I do? I can talk about, watch this. This is where I find mistakes. Is this right to say this? Because now you're saying that this stretch here is the same as that, right? What you're trying to say is that all 4 are the same. So you have to do this. Now you're saying that all these are the same, these are the same, and these are the same. Right? Yeah. For the kite, what are you saying then? Yes, you caught me. Yes. Did you catch that? I made a mistake up here. I'm saying that this is the same as that. So you need to change it up. You need to either do 3 here, right? Because you're saying that these are the same. Yes. Thank you. Good catch. Details, right? Anyways, that's what it is. Gotta watch out. All right. So I think you get the picture. I hope it'll show up tomorrow, most likely. I'll make you graph things, sketch things. It could be a rectangle, it could be anything. I could actually ask you a question. Hey, you have a chocolate bar. You're looking at it from the top. Tell me why that's a rectangle. Like, why would that be a rectangle? And you could say, well, it has 2 pairs of parallel sides, and all corners are 90. Boom, you get the 2 marks, right? So you got to be able to write it out and also just put some markings on the diagram. Okay. All right. 192. I think all I need to. 182 has a bit of a tree of quadrilaterals. I think it's like basically the 3 main branches are parallelograms, kites, and trapezoids. Under parallelograms, you have the rhombus, the square, and rectangle. So it's basically saying you can say, based on this tree, as far as down as you are, you can say that a square is a parallelogram. You can say that a rectangle is always a parallelogram. You can say that a rhombus is a parallelogram, right? So anything below the tree, right, belongs to the one on top, okay? So this is a little ways of maybe organizing your thoughts. But this is what I want you to highlight, or our circle, okay? You need to be as specific as possible. Okay, if you don't have a highlighter, you'll do one of these, right? Be specific, okay? Be specific, don't just say, oh, it looks like a rectangle. If I give you properties, I want you to narrow it down. This is actually a square, okay? So you gotta be specific. Okay, moving on. Let's do some math here. This is on page 193. So Bit of a loaded question here, but they're asking us to find AC, angle A, angle B, and they want to know what type of quadrilateral is ABCD, right? So ABCD, they want to know what type of quadrilateral this is. Okay, off the top, yeah, go ahead. This is a trapezoid, would you agree? Definitely a trapezoid. And because of this, right, I will say this. Base angles are congruent. Therefore, this is an isosceles triangle. So I've actually defined it before I started working with it, and that's what you should do. Okay, so this was step number 1. Step number 2, if you know that these angles are the same, what do you know about the side lengths? They're also the same. You have now, right, the option of saying this, and so this is 4 centimeters. So we're filling in information. So AC is this stretch here. So AC is the same thing as BD, which is 4 centimeters. Okay, so I'm just making a note here that these two sides are the same. They're both 4 centimeters. So you've answered the first part. Angle A. Oh, I forgot to tell you something. I gotta go back. This is where it comes in really handy what I'm about to tell you. Can you go back to 190? I need you to do this and make sure you do this because this is going to be very helpful. Look at a rectangle. 90 and 90 adds up to what? 180, right? That's always true. So you can make that conclusion, and you can also make that conclusion with a parallelogram. Angles that are like vertically across like that, you can bet that that's going to add up to 180 for our shapes here. So make sure you add the 180s everywhere. So when you look back, it makes sense. So we go rhombus and square. Again, 90 and 90 adds up to 180. So is the rhombus, and that's a bit of a problem for me. Nothing I can't handle. 180, 180. Why is that so helpful? Well, if you know this one, you can easily find the top just knowing that they add up to 180. Again, no secret here, no surprise, but this one is also going to be 180 every time. So all of the ones that are on 190, the kite obviously doesn't apply, right? But this one does. Sorry, I forgot to add that. So let's go back to 193 now. Because we needed that property to answer this. Because angle A, we know that these two add up to 180. Okay? So if this is 60, then this must be 120. So using this property, we can now answer that angle A must be 120. And angle B, guess what? It's true on this side as well. Right? It's also going to be 180 there. So this is 120 as well. So these are the answers they were actually looking for. And that's how I did that. And I'm going to find the area of this down here, but for now we'll forget about it. We'll just move on to this one here. This is a kite, obviously. Can't miss that shape, right? Like there's only one of them. And so they want to find WX and angle XYZ. So first of all, we make a note that if this is a kite, we know that this is the same as that, no surprise, we see that. And this is the same as that. So the 2 centimeters can be transferred over to this other side. And so WX, we can answer now, is the same thing as XY is 2 centimeters. And what's angle XYZ? Remember that? X, Y, Z. We know that for a kite, this angle is the same as that, right? These are congruent. So this must be 101. Okay? So this angle right here is 101. That's the one they're asking us for. So angle XYZ is 101 degrees. And I don't like that second question that much, but I think it's worth actually thinking about it. They're saying, what is the sum of these two angles? What are those two angles? WXY is up here, right? This one. And YZW, they're asking how much do these, so let's make an arrow going to them. This is that one, and this one is that one right there. That's the one they're referring to. And this is how I'm going to answer that. The sum of angles in a 4-sided shape is always what? It's on the top of page 190. It's 360 always. So we're going to say minus 101, which is this one here. And we're also going to subtract the other one. When you subtract that, you get 158 degrees remaining. So that means that the two angles they're asking us about, they have to add up to 158. So therefore, angle WXY, I don't like 3-letter notation, I agree with you, but that's how they do it. So this angle and that angle, the sum of that is 158 degrees. And that's it for that question. Determine, you need to copy this down. Determine the area of this shape. And I'm actually going to cheat a little bit and just copy the one from up there. So we're going to make this 4 centimeters. It's going to be the same as that one. This is going to be 5 centimeters, and this is going to be 9 centimeters. Sorry, you can't see that, can you? There. Can you quickly copy that? So remember, sine law, cosine law are very much alive still. They're alive and well, but in this case, we won't need it. This is what you need to do. You need to find the height of this thing. So dashed line, right? We're going to take that out. And we're going to redraw it. Please redraw it, or else you might not know where we got the numbers from. This is the height. And this is a 90. And how would I find this chunk here? And this is how I will do it. I'll take the 9. I will subtract 5 from it. And then you have the remaining has to be split between. Let's make another one here just so you understand. If you take the 9 minus 5 and you divide that remainder by 2, you will get what these stretches should be. Okay? So I'm going to go 9 minus 5 divided by 2, which is really 4 divided by 2. And that means that this stretch here is 2 centimeters. Does that make sense? If this had been, because I can't do all the examples, but if this had been a right trapezoid, would you have to divide by 2 after subtracting? No. Only now, because there's 2 triangles, right? You're splitting that difference among the 2. Anyways, how do we find height now? Pythagorean theorem. Don't be too excited. It's okay. 16 minus 4. That's 12. Hey, I never talked about this, but you could actually, if you wanted to use all decimals, you can just leave it like that, root of 12. And when you calculate the area later, you just plug in root of 12. I've never done that before, but you can do that. I will find out what root of 12 is. 3.4641 centimeters. So the area of a trapezoid is found by taking the shorter top length plus the bottom, multiplying that by the height of that thing and dividing it by 2. So A in this case is 5, B in this case is 9. You multiply it by the height, which is 3.4641, and you divide that by 2. Careful, very careful. So watch how I'm going to do this. 5 and 9, I can do that in my head. That's 14. But if you don't, you go 5 plus 9 equals times 3.4641 equals divided by 2. That's how I do it to be safe. And we are in centimeters. So you need to state that in centimeters squared. So I would strongly suggest you have the area of a trapezoid on your study sheet, just in case. But wait, that's not all. I'm just going to give you some homework here. Did I say homework? Did you just use the H word? Yes. Because our test is very close, I need to give you, it's basically what we did today. So write it down here. Homework, page. And it will seem like a lot, but it's not a whole lot. 195, 198, and 200. And trust me, one page has like 3 of these diagrams. It's not a whole lot. I will post the key. If I don't post it by like 5 today, let me know. I'll do that.